All right, here we are beginning practice exam 3. And now we're going to go ahead and go through this guy here to get it done. So we have, assuming the current carries, so we have this boat here. It's moving, if it moves in still water, it moves straight across like this. In water where there's a current, it's carried forward, or rather downstream, while being carried across. So let me just label a couple of things. I'm going to call this downstream. I'm going to call this here, I'm going to call it across. Woo, across. Okay. Now, assuming the boat is carried along by this current, we want to know the speed of the boat relative to the shore. Well, I even call this v relative, so it's very tricky of me. I'm very proud of this fact, and I've called it v relative. So v relative. I guess if you're clever, you're like, oh, it's a 3, 4, 5 triangle. I'm so clever. But for those of us that need to remember Pythagoras' theorem, that's the square root of 3 squared plus 4 squared, which is 5 meters per second. Now, if we want to know what angle the boat's at, we're going to take theta, so rather the tangent of theta using SOHCAHTOA. The tangent of theta is going to be 4 over 3, and the inverse tangent of 4 over 3 works out to be 53 degrees when we put it in our calculator. So, how long will it take the boat to cross the river? Ooh, so it actually turns out, we didn't say get directly across the river. It's not going to do that. It's going to take the same time to cross. It's just going to wind up downstream, and then we have to hike back to, our original crossing point, if that's what we're going for. All I'm saying is, how long does it take to just go from one side to the other? So we're still going to use this 4 meters per second to get across. So we're going to use y equals vyt plus y naught. And we have here 24 meters for our across distance from right here equals 4t plus 0. And we're getting 6 seconds to cross the river. Finally, we want to know how far downstream will the boat float as it crosses the river. Let's go ahead and get that. That actually has to do with this x speed. So x is the downstream direction. And so we're going to get x equals 3 times 6 plus 0, which ends up being 18 meters. All right. Now for question 5. A pumpkin is launched by catapult at 30 degrees and lands 40 meters away. So 30 degrees gives us a 40-meter range. What other angle could give us the same distance? Well, it actually turns out it's the complement of the angle. So 30 plus x equals 90 degrees. And x works out to be 60. All right, so that's the first 5 problems on the practice test. We will continue the next video with the next page.